Hello again, third grade, and welcome to lesson 2 of our motion and forces unit. Lesson 2 is going to focus on forces, on how forces can change motion. So we're going to go ahead and get started. The beginning of our lesson is going to give us our opening question that you're going to be able to answer independently. Three friends are playing golf. They each have different ideas about the force that acts on the golf ball. This is what they think. Finn thinks forces act on the golf ball only when the golfer hits the ball. Pete says forces act on the golf ball only when the ball is on the tee. And Tad says forces act on the golf ball when the ball is on the tee and when the golfer hits it. So you're going to select the person that you agree with, and you're going to explain why you agree with them. And that's going to be page 20. For page 21, we're going to look at this photo of the building being knocked down or demolished. How is force being used here, and what questions do you have? So take a minute to take a look at this photo. Think about what questions you have about what's going on here, and how is force being used to knock down or demolish this building. The next section is our STEM career connection, and you'll be reading about the demolition expert and answering your questions regarding that profession on page 22. For page 23, we're talking about how forces change motion. And for pages 23 and 24, we're going to be carrying out our inquiry activity. So we're going to do an experiment where we're going to be measuring how force affects the way an object moves. So we're going to think about what's the relationship between force and motion. What predictions, so you're going to make a prediction about what will happen to an object that you're pushing if you increase the force. Increase means to make more. So if you increase the force to make it move. I'm going to go ahead and scroll through our pages until we get there. So this is going to be our inquiry activity. It has the list of items that you'll need and the investigation and how to carry it out. Once you've completed the activity, you're going to answer the questions about what caused the car to move, what was the difference between the two distances traveled, and from your data is just another way to say information, so the information that you gathered. From your data and observations, how does a force affect the distance an object moves? So from everything that you learned here and everything that you saw, how does force affect the distance that an object moves? Once you've completed that section, we're going to go into our vocabulary for this lesson. Now, our vocabulary words for this lesson include the word force, friction, balanced forces, unbalanced forces, and accelerate. Force is any push or a pull. Friction is a force that opposes the motion of one object moving past another. So it's a force that goes in the opposite direction of where something is going. It's something that slows it down or makes it stop. So think about when you're rubbing your hand across a carpet. You feel that friction. You feel like the rug is pushing in the opposite, or the carpet is pushing in the opposite direction, making it hard for you to slide your hand across. Balanced forces act together on an object without changing its motion. So think about if you and your friend have your hands up against each other, right? Like you're giving each other a high five, but you hold your hand against each other and you're pushing with the same amount of force, your hands are going to stay in the same spot. Unbalanced forces are when one is more than the other. So forces that do not cancel each other out and cause an object to move. So if you and your friend are applying force on your hands when you're pushing your hands together and one person pushes harder, your hands are not going to stay in that same spot. They're going to move. You're going to get pushed in a particular direction, or you're going to push the other person in a particular direction. This is the same if you're both pushing on an object. If you use the same amount of force, you have balanced forces. So that object, that toy or whatever it is you're working with, is not going to move from that spot. But if there are unbalanced forces, so if someone much stronger is pushing on one side or they're pushing with more force, then that object is going to move. And our last word for this lesson is the word accelerate. Accelerate is a change in speed and direction over time. So think about when you're sitting in the car with mom or dad and they push on the gas pedal, like when they first start up the car, you can feel the car accelerate, how it's moving faster and faster from where it was before, from when it was stopped. Now that we have our vocabulary words, we're going to jump into the next section and we're going to watch a video called Force on how pushes and pulls affect motion. Then we're going to answer the question on page 25 that says, make a list of the types of forces you saw in the video. So keep an eye on the types of forces that you see, and then we're also going to jump into our textbook for the following questions.
Everything that moves, moves with what we call force. When you pick up a book, you lift it. The lifting motion is a force. When you throw a ball, the throw is a force. When you push your friend on a swing, your push is a force. Here's a tricky one. What force is this? Look at the direction and where the effort is starting. What force is this? Pull.
Okay, so go back and think about the different kinds of forces that you saw in the video. You saw different forces listed from the beginning to the end. So you can rewind and go back in case you forgot. Now, our next section, we're going to be reading about forces in our textbook. So you're going to open up your science textbook, which is called your science handbook, to page 226 to 227. And we're going to read those 2 pages. Forces. Objects do not move by themselves. A force must be applied to an object to change its motion. A force is a push or a pull. When you push on a door handle, you apply a force. The door moves away from you. When you pull on a wagon handle, you apply a force. The wagon moves towards you. Forces can be large or small. The force that a train engine uses to pull a train is large. The force that your hand uses to lift a feather is very small. It takes larger, stronger forces to move heavy objects than it does to move light objects. More than one force can push or pull on an object at a time. So anytime you're doing a push, you're moving something away from you. Anytime you're doing a pull, you're pulling something closer or towards you. Changes in motion. Forces can set objects into motion. Forces can also change the motion of an object that is already moving. Forces can affect a moving object's speed and direction. A force can also stop a moving object. So let's stop and think about that. So you can either get something moving by applying a force. If something is already moving, so think about if you're playing kickball outside or you're playing soccer, the ball is already rolling on the floor and someone else kicks it harder and it goes in maybe a different direction. So maybe it was going straight and now it's going to the right, and it may be moving faster now. So another force was applied to it that changed its speed and its direction, or it can hit something and stop. So a force can also stop the motion of an object. Think about forces that can change the motion of your bicycle. Applying force to the pedals makes your bicycle start moving. Applying force to the brakes slows the bike and stops its motion. The more force you use on the pedals, the faster your bike moves. The more force you apply to the brakes, the quicker your bike stops. Forces can also change the direction of motion. You can apply a force to turn the handlebars of your bicycle. This force changes the direction of the handlebars and the front wheel. The movement changes the direction in the whole that the whole bicycle moves. So think about if you're turning when you're riding your bike, you turn those handlebars, you're applying a force that changes the direction that your bike is going. A goalkeeper applies a force to throw the ball. The ball's motion starts. A player's kick applies force. The ball's motion changes in speed and direction. Catching the ball changes its motion as well, right? When you catch it, it stops moving. Now we're going to go ahead and answer the question on page 25. What type of force is needed to move a heavy object? So remember, when we were talking about different kinds of forces, take a look at the information on page 226, and that tells you what kind of force you need to move a large or heavy object. Next, we're going to go into page 26. And for page 26, we're going to explore a simulation about changing forces. So we're going to hit the targets in each level, use the arrow controllers to set the speed and direction. Select push to set the puck in motion. Apply an equal and opposite force to stop the puck. Finish a game in as few steps as possible. The puck can move up, down, left, right, or diagonally. So we're going to explore this activity, and then we're going to answer the question, what happened when you changed the direction of the force? Now, if we apply a lot of force, we apply a push, it's going to keep moving in that direction. If I apply a little bit of force in the opposite direction, it slows down a bit. If I apply a little more, it slows down a bit more. And if I apply a lot of force, it should stop moving. So the idea is to try and get it. So we hit our first target. We want to try and hit our second target. So we're going to apply forward motion first and see if maybe we can nudge it a little bit in the opposite direction to get it to go where we want. So let's keep trying. We want to make sure we get it over to number 2. And then we're going to try and stop it at that target. So let's see if we can get it to stop. Almost, not quite. So we'll see if we can get it to stop on number 2 in as few moves as possible. So this one, because it wasn't quite where we needed it to go, it wasn't able to stop on the right spot. So over here, we almost made it. We didn't make it quite far enough. So what happened when you changed the direction of the force? Think about what happened when we applied a little bit more force in one direction than we did in another. All right, moving on, we're going to jump into the next portion where we're going to be answering questions 4 and 5 on page 26 as well. We're going to read pages 228 and 229 here in our science handbook about types of forces. Okay, now we're going to talk about different kinds of forces. We have contact forces, we have friction, and we're also going to talk a bit later about non-contact forces. So contact forces. There are many types of forces. The forces you are probably most familiar with are contact forces. Contact forces happen between objects that touch. Think about a baseball game. The pitcher must touch the ball to throw it to the home plate. A bat must touch the ball to change its direction. A player's glove must touch the ball to catch it. When the bat hits the ball, it applies a contact force. So contact forces means something touch, they come in contact with each other. Next, we're going to read about friction. A block slides on the floor, then it slows down and stops. Why does the block slow down and stop? A contact force called friction is acting on the block. Friction is the force that occurs when one object rubs against another. Friction pushes against the moving object and causes them to slow down. Different surfaces produce different amounts of friction. Rough surfaces, such as sandpaper, produce a lot of friction. Smooth surfaces, such as ice, usually produce little friction. The water slide is smooth, so it has little friction. Increasing friction. When you increase something, you make it more. Sometimes it is helpful to increase friction. People use rough or sticky material to increase friction. The brakes on the bike use rubber pads to increase friction. When you squeeze the bike handles, the brake pads press against the rim of the wheel. The friction between the pad and the rim causes the bike to stop. Reducing friction. At other times, it's helpful to reduce friction. People use slippery things to reduce friction. Oil is often put on moving parts of the machine to reduce friction between them. Without oil, friction between the moving parts of the engine will cause the parts to wear out. If you have been to a hockey game, you might have seen an ice resurfacer used to polish the ice. This machine puts down a thin layer of water to make the ice smoother. This layer of water reduces the friction and helps the players skate faster. The machine cleans and smooths the surface of the ice, reducing the friction. Now that we read page 228 and 229, we're going to answer the questions. Number 4, what is friction? And number 5, how can you increase friction? So what is friction? We're going to find out right here on page 228. And how do you increase friction? We're going to find that at the top of page 229. All right, next we're going to go on to page 230 and 231 in our science handbook, and we're going to answer this question. What does the force of gravity on an object depend on? Now, we're going to be talking, based on the reading for 230 and 231 here, we're going to start talking about what we call non-contact forces. Not all forces are contact forces. Some forces can act on an object without touching it. These forces are non-contact forces. Magnetism, electricity, and gravity are examples of non-contact forces. Magnetism. Have you ever used a magnet? What did you notice? When you bring the magnets near each other, they can attract or pull on each other to bring each other closer together, or they can also repel or push away from each other. Magnets do not have to touch to attract or repel each other. The force that causes magnets to attract or repel is called magnetic force. A magnet is an object with a magnetic force. Magnets do not only affect each other, they can also attract objects made of certain materials such as iron. Magnets cannot attract objects made of wood, glass, plastic, or rubber. Magnets can also apply magnetic force through objects or through other materials. They can attract or repel objects through solids, liquids, or gases. A metal paperclip contains iron. A magnet can pull on a metal paperclip without touching it. Sometimes trains run on magnets that repel from the track. They produce little friction so that they are very fast. What could I be? Transportation engineer. Transportation engineers design vehicles and systems to move lots of people quickly from place to place. They use what they know about forces and friction to build trains and tracks that move as fast as possible with the least friction and the least energy. Learn more about being a transportation engineer in the career section. Now, another non-contact force is electricity. Objects can have electrical charge. Electrical charge causes electrical force, which is a non-contact force. If two electrical charges that are alike are brought near each other, the charges repel each other. So think of a magnet, how sometimes when you try and put both the north sides together or both the south sides together, they push away from each other. You can't get them to touch. That's what they mean by repel. They push away from each other. If two electrical charges that are alike are brought near each other, the charges repel each other. If the two charges are different, they attract each other. Look at the girl in the picture. Each hair on her head has the same electrical charge. The like-charged hairs repel each other. So notice how her hair is standing up and pushing away from the rest of her head. That's how you know that those are, it's a non-contact force because it's the electricity that's going through it. And we know that they are like charges. That means they're the same because they're pushing away from each other. They're not sticking to each other. Gravity. Gravity is another non-contact force. Gravity is a pulling force between two objects. Gravity pulls objects such as you and the Earth together. When you jump, Earth's gravity pulls you down. The force of gravity between two objects depends on how much mass the objects have and the distance between the objects. Objects with more mass have a stronger pull. For example, the mass of the Earth is huge. Its gravity pulls strong on all objects. Earth's gravity is what keeps us on the ground. Gravity is also stronger when objects are closer together. So over here, we're talking about objects that have greater mass. Now, mass is not the same as weight. Weight is basically how much gravity is pulling you here on Earth. Your weight changes depending on where you are. So if you were to get on a scale here on Earth, you might weigh 50 pounds, but if you get on a scale on the moon, it's going to be a whole lot less because there's less gravity pulling you towards the moon. But your mass stays the same wherever you are. So mass is basically how much stuff you're made up of. So think about a balloon and one of those rubber bouncing balls, right? The balloon weighs less than the rubber bouncing ball, even though it's larger, because most of what the balloon is made up of is gas, right? There's not very much mass to it. There's just the thin balloon, rubbery material. But if you have one of those solid bouncy balls, those are all rubber. So those are heavier. They have a greater mass also because they're made up of more stuff. So if you're dropping both of those, if you have a balloon that you blew up and one of those bouncy balls, gravity is going to pull harder on your bouncy ball because it has a greater mass, right? It's made up of more stuff. Your balloon will fall a whole lot more slowly. Gravity will still pull on it, but not with the same amount of force that it pulls on an object that has greater mass. So that's a little bit of background information for you guys. Now, moving on, we have page 27. We have another inquiry activity about balanced forces. So we're going to be looking at how to make balanced forces by creating our own little balance scale. Now you'll have the materials and the directions here. You're going to document all of your answers as you go. You're going to fill in your responses on the following page, on page 28. We're going to construct an explanation. That means we're going to write out and explain our answer. Were you able to balance the force on the objects? Did the results match your prediction? So what you thought was going to happen? Read page 232 and 233 in the science handbook, and we're going to answer the questions. Describe the forces in balanced forces and which forces cause a change in motion. So we're going to go ahead and hop back into our textbook and take a look at our next set of pages on 232 and 233. Types of forces. The first one we're going to talk about is balanced forces. When a batter hits a baseball, he or she applies a force. Other forces, such as gravity, are at work too. How do all the forces acting on an object affect its motion? When you put a heavy backpack on your desk, the backpack does not move. Gravity pulls the backpack towards the earth, but your desk is in the way. The desk pushes up on the backpack, also with a force. The strength of the force is exactly equal to the pull of gravity. Those forces are balanced, right? So once you put your backpack down, it stays put. It's not sliding around. It's not pulling down through your desk onto the floor. It's not floating back up. Balanced forces are forces that cancel each other out when acting together on an object. The forces are equal in size and they are opposite in direction. Balanced forces do not cause a change in motion. When an object is sitting still, all the forces acting on it are balanced. If the puppies pull in the opposite direction with an equal force, the shoe doesn't move. The forces are balanced. Unbalanced forces. Suppose you push the heavy backpack across your desk. There is friction between your backpack and the desk. The force of friction is weaker than your push. How can you tell? Because the backpack moves, right? You're applying more force than the friction that's acting on it. And that greater amount of force is making the backpack move. Forces that are not equal to each other are called unbalanced forces. Unbalanced forces cause a change in motion. The greater force determines the direction of the motion. So the side that's pushing harder is going to decide which way your object is going to move. Your backpack moves in the direction that you push. Look at the dog sled shown in the photograph. Before the race, gravity held the sled in place. Then the dog started to run. The force they placed on the sled was greater than gravity and friction. Forces were unbalanced, and the sled started to move. Unbalanced forces can affect an object's direction, speed, or both. The sled now goes in the direction that the dogs run. The faster the dogs run, the greater the speed of the sled. So you're going to go ahead and answer these two questions. Describe the force in balanced forces and what causes a change in motion. And that's going to take you to the end of page 28. This is where we're going to stop for this lesson. Actually, my apologies. We are going to continue moving into page 30. So we're going to read page 234 and 235 in our handbook. We're going to talk about our other vocabulary word, accelerate, and we're going to just decide what does it mean to accelerate. And question number 12, what of the two bicycles might accelerate more rapidly? A big old heavy bike with a basket filled of stuff, or a more thin light one? For page 235, we're going to read through that in our science handbook, and we're going to look at the drawing that shows that the load accelerates half as fast as the first drawing. So the third drawing shows that the load accelerates half as fast as the first drawing. What is causing that change? Let's go ahead and hop back into our book to page 234. Types of forces. Defining acceleration. You can measure the distance an object moves. You can also measure the time it takes an object to move that distance. From these distance and time measurements, you can determine the speed of the object's motion. The motion of an object is described by its speed and its direction. Speed and direction can change. Look at the speed skaters in the photograph. As these skaters race around the track, they speed up and slow down. They turn to their left at both ends of the oval track. Any change of their speed or direction is called acceleration. Think about the gas pedal in a car. Another name for the gas pedal is the accelerator. The pedal is also known by this term because it causes the car to accelerate or change speed. Pressing on the pedal makes the car move faster. Releasing the pedal lets the car slow down. The skaters accelerate when they change speed and direction around the track. Forces affect acceleration. To jump, you push against the ground. To jump higher, you push harder. If you swim, you know that to move faster, you must push harder against the water. The size of a force affects the object's acceleration. A greater force gives you more acceleration. The mass of the object matters too. If you apply the same force, an object with more mass will accelerate more slowly. In the first drawing below, one person pulls the load. The load accelerates. In the second drawing, two people pull the same load. Now it accelerates twice as fast. Why? Because two people apply twice the force on that same load. What happened in the third drawing? One person pulls a load that is twice as large. She uses the same amount of force as the first drawing. The load accelerates half as fast. So let's take a minute to really take a look at this picture and these diagrams. So when you have one person pulling on one load, this is, a giant pumpkin, they can make it move because the force that they're applying, that pull that they're applying, is making it move because that force is greater than the friction underneath. It's greater than the force of gravity on it. In the second picture, we have two people pulling that same load. So it's going to move faster because now you have twice as much force, but the load is still the same. But the last one, you have twice the load. So you're pulling something that's twice as heavy, but you're using the same amount of force. So it's not going to move, or it's going to move very, very slowly. So in order to answer your questions on page 230, for number 11, what does it mean to accelerate? Your answer for that is here on page 234. For number 12, which of the two bicycles might accelerate more rapidly? So think about what we learned. A big old heavy bike with a basket filled with stuff, or a thin light bike? Now our last question on page 230 is question number 13, and we're going to read page 235 to be able to answer it. Whoops. We're going to review page 235 here to be able to answer it. Okay, on the third drawing shows the load accelerates half as fast as the first drawing. What causes this? So why is this going to move half as fast as this first one? Take a look at the load on each one to help decide your answer. Now, once we've completed that, we're going to jump back into our lesson. And we are going to move into our simulation. So we're going to revisit that same simulation we were working on, and we're going to answer the questions. What happens to the acceleration of the puck as you increase the force? How are you able to completely stop the puck? So think about what we were doing over here. We can reopen this. Our first question, what happens to the acceleration as you increase the strength of the force? So let's start with a small push. Let's make it a bigger push. Notice what's happening. Make it a really big push. Now what's happening? Now what do we need to do to slow it all the way down or to stop it? So if we apply a small force, is that going to be enough to do it? No. What if we apply a large force? So we need to make sure we balance the forces. So take a look at the arrows that you're seeing in our puck. So if there's two arrows pushing up, we're going to need two arrows pushing down to make it stop in order to apply an equal and opposite force to balance it and to make it stop. So number 14, what happens to the acceleration as you increase the strength of the force? So think about what happened when we were making it go faster and faster. And how are you able to completely stop the puck? Those are going to be your answers, or those are going to be your questions for page 31. All right, now that we've completed that page, we've completed page 30 and 31, we're going to move back and take a look at what we have next in our lesson. After that, you've got another inquiry activity where on page 32 and 33, where we're going to be conducting an inquiry activity to identify how friction affects forces. So we're going to think about what friction does to our forces by using a lot of different types of material and rolling our toy car, deciding how much friction how that friction is affecting how far our car is going and the speed and movement of our objects. Once you've completed answering your questions on page 32 and 33, page 34, you're going to be completing your performance task where we're going to build, where we're going to do our mini building demolition. So using cups and a rubber ball, you're going to follow the directions to figure out how to knock down your cup structure that you build, or your little cup building. But you have to follow the directions that they have. So you have to knock it down so a certain number of cups stay up, or only knock down a certain part of it. So that's a fun activity that you guys are going to work on page 34 and 35. That will take us to the end of lesson 2. If you guys have any questions, definitely let me know. Otherwise, I hope you have a wonderful day. Take care, 3rd grade. Bye-bye.